Hey Rock Buds, it's Rock Papa. I hope you guys are doing well. Today we're going to talk about 3 interesting mafic rocks, Gabbro, Diabase, and Basalt. We're going to find out what they are, what they're made of, and where you find them. So if this video is interesting and helpful, please subscribe, and thank you a million to all my wonderful subscribers. Okay, so here we go. Gabbro, Diabase, Basalt. Gabbro, Diabase, and Basalt are mafic rocks. That means they are high in iron, calcium, and magnesium, and low in quartz. And they are igneous rocks. That means they come right out of the mantle as is. In other words, they are not sedimentary rocks and they are not metamorphic rocks. You will likely be glad to know that all 3 of these rocks contain the same minerals. We're talking about pyroxene, which is a black mineral, and we are talking about calcium-rich felspar, which is a white mineral. Also, there might be a little bit of hornblende, which is a black mineral, and a little bit of olivine, which is a greenish mineral, but not much of those. And hey guys, the black mineral that's in all 3 of these rocks, pyroxene, will not scratch with a nickel coin. A helpful hint. Let's take a look at Gabbro. And you'll notice that Gabbro is, generally speaking, a darkish rock. You may also notice that the crystal sizes, the mineral sizes, are pretty big. The black mineral spots that we see are pyroxene. And notice the white mineral spots. This is the calcium-rich feldspar. And notice how they look a little rod-shaped or stringy. They can also look blotchy and ragged like these. And they can even look like a kind of network of veins or roots like these. Here's some granite by comparison. The potassium-rich feldspar is white, and these mineral grains are kind of like blobs, not rods or stringy looking. Hey Rock Buds, geologists call this interesting crystal shape lath-shaped crystals. And if you look at my hair, you might see a relationship there, shape-wise. Here is how Wikipedia describes these crystals. Now let's take a look at some diabase. Same minerals as Gabbro and Basalt, pyroxene and calcium-rich feldspar. And you probably notice this is a pretty dark rock and that the mineral crystal sizes are much smaller than those of Gabbro. Here's another example. You can see the minerals with the naked eye, but they are quite small. And you might notice that the calcium feldspar crystals, though they're very small, are still not blobby. They're kind of stringy or rod-shaped, kind of stretched out lath shape. This is Mount Moran in Grand Teton National Park. Most of the mountain is granite or granite gneiss, but look at that black streak of diabase running through there. That's going to give us a hint as to what diabase does. And we'll hear more about that in a minute. And here's a big old diabase dike in Piedmont, Georgia, slicing its way through a granite gneiss formation. Notice how fine-grained it is. I really can't see the crystals here. And now we're looking at samples of basalt. This is vesicular basalt, which just means it has these holes which are former gas bubbles in it. But you don't see a lot of mineral crystals here. This sample is from the Snake River, Idaho basalt flow, and on the left I can see some white stuff. I believe that's some of the calcium from the calcium-rich feldspar that's leached out onto the outside, and this would likely fizz in an HCl solution. And here's some more of that same stuff, and you can see magnified here, teeny, tiny little crystals of minerals. And here's some basalt lava that's in the very process of cooling, and probably this cooled so fast that no mineral crystals develop. In other words, there was no time for crystals to grow. And as you guys likely know, when magma has a lot of time to cool, when it cools deep underground, it may take hundreds or thousands of years. That's plenty of time for bigger crystals to grow. If it pops out on the surface as basalt and cools very quickly, that's not enough time for crystals to grow. So the crystals will be teeny tiny, that's a technical term, or non-existent. Hey guys, so now that we've looked at these three very interesting rocks, let's find out how they form and why they are different from each other. Here is supercontinent Pangaea getting ready to rift apart. Molten mafic magma begins to pool under the middle of Pangaea, begins to rise up, cracking the crust, shooting hot magma dikes up through the crust, acting like blowtorches that break the crust apart. Finally, magma breaks through the crust, erupting in massive basalt lava flows. Over time, a lot of the magma in the gigantic pool below the land crust will slowly cool and grow big crystals, and that's where our gabbro comes from. The magma that shoots up in these dikes but never reaches the surface cools a little more quickly than the gabbro, giving rise to the rock diabase with smaller crystals. And the diabase that does reach the surface, erupting as basalt lava, cools even faster, giving rise to small or non-existent crystals. As the supercontinent continues to break up and split apart, an ocean is formed in between. The same eruptive processes that we've just discussed. This creates more and more ocean crust. So let's see what ocean crust is made of, and I bet you already know. Laying just about right on top of the mantle is a bunch of gabbro. Shooting up from these hot gabbro bodies are dikes of diabase. Geologists called them sheeted dikes or sheeted dike complex. And as you might expect, on top of the sheeted dikes and just below the sediment layers of the ocean bottom is basalt lava. This basalt lava is called pillow lava because of the way it comes out and cools so quickly like this. Once it cools, it looks like a bunch of pillows. When two continents crash together, very often the ocean crust that's in between them gets shoved up onto land. And so you can see the sheeted dike complex, which is made of diabase and basalt, just sticking up on land like this. This is the Giant's Causeway in Ireland. Okay, most excellent rock buds. To summarize, gabbro, diabase, and basalt all have the same mineral makeup. That's pyroxene and calcium-rich feldspar mostly. Pyroxene is a black mineral, and a nickel coin will not scratch it. And a nickel coin will also not scratch hornblende, but a nickel coin will scratch black biotite. And the calcium-rich feldspar crystals in these mafic rocks can have weird forms. They're not blobby like potassium and sodium-rich feldspar crystals. They're stretched out, rod-shaped, lath-shaped, kind of platy and ragged shape. Gabbro is found deep underground where it cools very slowly, giving rise to large crystals. Diabase comes very close to the surface but doesn't bust out on the surface, and it has less time to cool, so the crystals are not big at all. And then basalt lava erupts onto the surface and cools so quickly, especially if it falls in water, that little or no crystals are visible. And finally, these three rocks make up ocean crust, which is one of the two kinds of crusts we have on planet Earth, the other being land crust. And so guys, that's it for now. Hope you enjoyed this video, and thank you so much for watching it. And if you did enjoy it and it was useful, please subscribe. And this here is your rock papa saying happy rock hunting to all my wonderful rock buds. Papa out.